Hello everyone, I am Sanonda, a third year PhD student at the University of Maine. Today I am going to present our paper titled PHIN, a privacy protected heterogeneous Internet of Things network. This is the high level overview of our presentation. First, we are going to briefly discuss what is Internet of Things and the motivation of our research. Next, I will discuss closely related work present in privacy in the Internet of Things, and then I will discuss about the limitations. Finally, I will raise some research questions motivated from the related work and the current privacy concerns, and which we are aimed to answer through our framework PHIN. Then we will show some preliminary analysis of our framework and discuss the result of the analysis. Finally, I will conclude the presentation by discussing our future work. Okay, so what is Internet of Things? Internet of Things, or IoT, is basically a combination of physical objects or things that are embedded with sensors and softwares, have the ability to collect and transfer real-time data, and they can also interact with each other via internet. According to the IDC, or International Data Corporation, it is estimated that by 2025, more than 40 billion Internet of Things devices are going to be deployed that can raise more than 79.4 zettabytes of data, which is huge. This increasing growth of deployment raises several privacy concerns. For example, IoT devices are complex and diverse, which lead developers to use diverse APIs. Researchers have shown that the usage of diverse APIs basically leads to the usage of incorrect APIs. That raises several privacy concerns. For example, collection of data that are not related to its functionalities, or mismatches or inconsistencies between application behavior and its privacy policy. By inconsistency, we mean that when an application is collecting your data, such as location, but it is not mentioning it in its privacy policy, we basically identify such cases as potential inconsistency. This is a high-level overview of real-life example. It's an excerpt of iRobot privacy policy that says that iRobot basically provides open access to its third parties to the collected data, and the third party can share and process the data according to their privacy practices. Providing such open access raises a privacy concern such as inference of personal information by the common third party between iRobot and other devices. Another common feature in IoT devices are their limited capabilities while interacting with consumers. The lack of user interface means that lack of real-time notification mechanism for the consumers. Hence, the common way or most preferred way to notify consumers about their data practices is through privacy policies. It is shown by the previous research is privacy policies are complex legal jargon, difficult to understand because of their complexity, time consuming to read because of their unnecessary length. It is also shown that privacy policies are unable to get updated real time according to their life cycle of the IoT devices. Once we have discussed about the motivations, we wanted to actually see that what are the related work and their limitations in the field of privacy in IoT, or more specifically in the three important topics. First, analyzing privacy practice consistency, inference risk of personal information, and providing privacy notice. Under analyzing privacy practice consistencies, previous research common approach was to conduct a static analysis on application source code, and the result shows that it is possible that there is mismatches of data collection, and also companies share their data, users' data, without even users' consent. But the limitation of the present work is maximum work is basically focused on mobile-based application rather than IoT devices. The second topic is inference risk of personal information. Present work shows that it is possible to infer users' activity by analyzing collected data of a single IoT device. But the limitation is present work only focus on collection of data of a single IoT device rather than focusing what will happen or what are the consequences when several devices are connected within the network. Providing privacy notice or effective privacy notice has always been a major research problem in privacy. Common approach in this case is basically analyzing existing mechanism, providing detailed privacy notice, or understanding users' privacy concerns. The result shows that users are more concerned on unauthorized access to their personal information. Some research also basically attempted to provide a privacy level for detailed privacy notice, but the limitation is currently all this work is basically focused on only providing privacy notice rather than identifying potential privacy risk and generating a potential privacy risk report to the consumer so that they can be helpful for them to understand what are the risks of installing a new device within their network. Considering the related work and the motivations and the privacy concerns we have just discussed, we wanted to actually delve into a real life scenario. Consider that there is a user who is using a smart bulb, a smart fridge, and Amazon Alexa, a smart assistant that are basically interacting with the smart bulb and a smart fridge. Now the user wants to install a new device, let's say a smart robot, a smart vacuum cleaner, let's say. But the user is confused because the user wants to know what if they infer my personal information, or if the data collected according to its privacy policy, or maybe if am I able to know about this privacy risk before I deploy the device. So these are basically the research questions we are aimed to answer through our framework. In order to answer these research questions, we developed a framework called PHIN, Protected Heterogeneous Internet of Things Network, that has 4 major components: information extractor, privacy checker, privacy risk analyzer, and notice generator. PHIN aims at identifying privacy risks from 3 different perspectives, as we can see from the figure: checking inconsistency, checking inference risk, and also checking compatibility. At present, we are only focusing on first 2 perspectives. PHIN also aims at analyzing the privacy risk and assigning privacy risk level to a new IoT device, and can generate 2-layer privacy risk report through the notice generator framework. In order to basically achieve this goal, the first major component, that is information extractor, aims at basically analyzing and extracting 4 different information. First is sensitive data types. Sensitive data types is basically information that requires the usage of sensitive APIs in the source code. As we can see in the figure, in order to basically access location in Android application, they are required to use get last known location sensitive API. We have analyzed Android public documentation and identified 132 sensitive APIs and mapped them to its corresponding sensitive data types. Next, we extracted policy phrase. We have to basically identify the inconsistency between the new IoT application and its privacy policy. For that, we have to analyze privacy policies. Policy phrase is basically information mentioned as collected information in the privacy policy. We have analyzed 75 IoT privacy policies and extracted 79 policy phrases. As we can see from the figure, geolocation and temperature level are basically information mentioned as collected information in privacy policy. We mapped them to its corresponding policy phrase, location, and temperature. This mapping helps us to get rid of the cases such as synonyms and hypernyms. Next, we also categorize the policy phrases within 8 categories. Since IoT devices collect different types of information, such as health-related information and environmental information, and for users, the types of information and their sensitivity varies, we wanted to basically categorize the policy phrases within 8 categories. The fourth information is basically third-party category. The information extractor extracts from privacy policy. As we can see from the figure, advertisement, Facebook, Instagram, and social media are basically the third-party categories or third-party names mentioned in privacy policies. So we basically extract these third-party names or categories and map them to its corresponding 14 third-party categories mentioned in privacy-grade website. Why we are considering third-party categories rather than third-party names? After analyzing 75 IoT privacy policies, we have noticed that privacy policies are likely to mention the third-party category names than third-party names itself. Once we have extracted sensitive data types, policy phrase category, policy phrase, and also third-party categories, now basically information extractor passes this information to privacy checker. Privacy checker basically checks risk from inconsistency checker's perspective, as well as inference risk checker perspective. Checking inconsistency rate between the new device and its privacy policies is we basically extract sensitive data types from a new IoT device source code and also extract policy phrase. Then we calculate the number of common information between sensitive data types and policy phrase. Here, SX is basically sensitive data types of device X, and P phrase X is basically policy phrases of device X. Then we calculate the number of total information between sensitive data types and policy phrase. Then, using the given equation, we calculate the inconsistency rate. In order to basically calculate inference risk rate, we require third-party categories and policy phrase categories. We calculate the ratio of common policy phrase categories between the device X and already deployed IoT device N, as shown in P1. And then we calculate the ratio of common third-party categories between device X and already deployed device N, as shown in P2. Here, W1 and W2 are basically sensitivity weight set to 0.5. This sensitivity weight can be adjusted based on the types of information being collected, which is our policy phrase categories. And we are at present basically providing equal importance to both third-party categories and policy phrase categories. Thus, we basically assign 0.5 to W1 and W2. Once we identify inconsistency rate and maximum inference risk rate, we basically assign risk level to a new IoT device X within low, medium, and high, as shown in this figure. We basically check the value with the low, medium, and high bar, and then we assign the corresponding level to the new IoT device X. Once we are done with assigning privacy risk level, privacy risk analyzer sends all this information to notice generator. Notice generator basically generates two-layer privacy risk report based on the risk analysis of new IoT device. As we can see from the figure, the first layer consists of brief risk report, such as what is the device name, if there is any inconsistency, if there is any common third party between deployed devices, and inference risk of personal identifiable information. In second layer, we give more detailed risk report, such as the percentage of the inconsistency rate, or what is the maximum risk of inferring personal identifiable information. We additionally also provide some other data practices information, such as what is the purpose of collecting those information, how long the information is going to be stored, that is the retention period, and how consumers will be able to access the shared data. A link to the device's privacy policy is also embedded in the privacy risk report. We evaluated conceptually our framework with 4 real IoT applications. As we can see in the table, this is the partial data set where FIS has been evaluated. We basically collect data and conduct a static analysis to extract data from Withings blood pressure monitor, that is our new IoT device, and the other 3 devices, that is Arlo Home security camera, Dyson, which is basically a smart vacuum cleaner, and Anova precision cooker, which is basically a smart cooker. These 3 devices are already deployed, and we basically want to see, before the Withings blood pressure monitor should be deployed, what is the privacy risk and how we can generate a potential privacy risk report. We followed the concept mentioned in before, as we mentioned in previous slides, and identify inconsistency rate and inference risk rate. Here we can see that the maximum inference risk rate is basically 66%, and inconsistency rate is basically 36%. As per discussion, FIN successfully can identify inconsistency between an IoT application and its privacy policy and inference risk of personal information by aggregating data from other devices. FIN can generate 2-layer privacy risk report, where layer 1 describes brief privacy risk report and layer 2 describes detailed risk report with additional data practices. For the future world, we aim to basically extend our API mapping dataset by considering API outside of Android, such as Google APIs. And also we want to understand the sensitivity weight of the collected information and adjust the sensitivity weight. For this, at present, we are conducting a usable study. And we basically want to see that what users think the degree of sensitivity of the collected information of the IoT devices. We also want to extend the privacy risk by considering consumers' privacy preferences and comparing it with the privacy preferences provided by the new device. Finally, we also want to implement, we are also focusing to implement major components of our framework and evaluate the functionalities in a largest heterogeneous network. To end the presentation, first I want to say that it is really important to have data for research, but it is also important to protect the collected data. And I'm ending my presentation here. Thank you very much. If you have any question, feel free to ask me. Thank you.